All right, welcome to the Explainer. Today, we're diving into a technique that's absolutely essential for anyone building with AI, agent tracing. Look, if you're wrangling teams of AI agents, you already know they're incredibly powerful, but you also know how much of a nightmare they can be to debug. Well, today, we're going to talk about how to fix that. So think about these multi-agent AI systems less like a single monolithic tool and more like a super specialized team of experts. You've got different agents all working together, each a pro in its own field, tackling these huge, complex problems that one single AI just couldn't dream of handling alone. It's a game changer, for sure. But, and this is a big but, there's always a catch, right? When this intricate dance of agents falls apart, trying to figure out what went wrong can feel, well, impossible. Honestly, the hardest part isn't even building these things anymore. It's figuring out why they broke when some tiny, silent error grinds the entire system to a halt. Okay, so let's get into it. To really get why debugging is such a beast, we first have to understand why we're even using teams of agents to begin with. The reality is, most of the problems we're trying to solve aren't simple one-and-done questions. Nope, they're messy, they have a ton of steps, and they demand real reasoning, planning, and action. Take a coding task, for example. It's a perfect illustration. You're not just going to have one agent trying to do everything. No way. You're going to need an orchestrator to map out the big picture, a coder to actually write the code, an executor to run it and see what happens, and you'll probably even need a file surfer and a web surfer to grab info. Each one is a specialist, and for the whole thing to work, they have to collaborate flawlessly. And this quote just hits the nail on the head. It perfectly captures the central paradox here. The very thing that makes these systems so powerful, this whole distributed, specialized approach, is exactly what makes them a nightmare to fix when something goes wrong. Their greatest strength is also their biggest weakness when it comes to debugging. And all that complexity, it leads us straight into what I call the debugging black box. It's this place where when something breaks, it feels like you're completely in the dark. You're not just hunting for a bug in a line of code anymore. Oh no. You're trying to diagnose a flawed conversation, a single miscommunication between two smart agents that caused the whole thing to collapse. So what are we dealing with inside this black box? First up, cascading errors. This is like a domino effect. One agent makes a tiny, almost invisible mistake. Maybe the file surfer grabs the wrong version of a file. That bad data then goes to the coder, who writes perfectly logical but ultimately wrong code. Then the executor tries to run it, and boom! The crash you see is the last domino to fall, but the problem started way, way back in the chain. Next, we have what's called opaque reasoning. This is a huge one. Without being able to see inside an agent's head, you have no idea why it did what it did. You're left asking yourself, why on earth did the orchestrator think that was a good plan? Or what was the coder's logic there? It's a total black box, and you're just left guessing. Now, this next one is really interesting. Emergent interactions. Sometimes you can have a team of perfectly good agents, none of them are individually broken, but when they work together, something weird happens. They create these new, unhelpful, and totally unexpected behaviors that just derail the whole project. It's like having two brilliant coworkers who, for some reason, just can't work together productively. It's the team dynamic that's broken. And last but not least, let's talk about tool failures. Your agents are constantly using external tools, right? They're hitting APIs, querying databases, you name it. But did the tool even work? Did the API throw an error? Was the data it sent back in a weird format? Again, without a way to see what's happening, you're flying blind. So with all these challenges, how do we possibly solve this? How do we flip the lights on inside that black box? Well, the answer, the core foundational technique, is something called agent tracing. And honestly, it's pretty much what it sounds like. Think of agent tracing as creating a super detailed step-by-step receipt for your entire agent workflow. Every single message that gets passed, every decision an agent makes, every time a tool gets used, all of it is logged and laid out visually for you to see. And the difference this makes is just night and day. It's a tale of two workflows, really. Without tracing, you're basically living in a world of guesswork and long, painful debugging sessions, ending up with an unreliable system. But with tracing, you move into a world of actual root cause analysis, super fast fixes, and building AI you can actually trust. Now, tracing is the fundamental idea, right? But to actually put it into practice, especially at scale, you're going to need an observability platform. These are the tools like Maxim AI and others
that are built to take all that raw trace data, which can be super noisy, and turn it into clean, clear insights that you can actually use. So, what's the first big problem that a good platform solves? It's helping you see the conversation. And I don't mean a simple back and forth. The communication between agents is this wild, complex, branching dialogue, and trying to follow it in a text log is just not going to happen. That's where visual trace views come in. A good tool gives you a map of the entire interaction. You can literally see how a task gets handed from the orchestrator to the coder, you can track how information flows between them, and most importantly, you can pinpoint the exact spot where the communication breaks down. Okay, but what about when you find a bug that's buried deep inside a long workflow? I mean, what if the error happens on step 20? You can't just restart the whole thing from the beginning every single time you want to test a fix. That's just a recipe for losing your mind. And that's where a feature like checkpoints becomes an absolute lifesaver. It's like having a rewind button. A great platform will let you jump back in time to the moment right before the error occurred. You can literally pause everything, edit an agent's instructions on the fly without changing a single line of your actual code, and then hit play to see if your fix worked. This is what rapid iteration looks like. Look, having the right tools is a huge piece of the puzzle, but it's only half the battle. The other half is having a solid process. It's not enough to just have tracing. You've got to use it the right way. So let's lay out a quick action plan for you. Okay, so here are the 5 best practices. First, you've got to implement comprehensive logging. The rule is simple. If you don't log it, you can't see it. Second, use interactive visualization tools to turn those logs into something you can actually understand. Third, you need to integrate evaluation pipelines. Mix automated checks with real human feedback. Fourth, iterate on your agent configurations. Use what you're learning from the traces to make your prompts and workflows better. And finally, number 5, monitor it all in production. This turns tracing from something you only use when things are on fire into a proactive way to build rock-solid AI. And let's just double-click on that first step for a second, the comprehensive logging. As your systems get more complex, the little details become everything. That's why you see some platforms now supporting trace elements up to 1 megabyte. Now, that might sound like just a number, but what it means is you can log way more detailed information, like an entire file an agent is reading or a huge, complex API response. You get all the context you need to actually solve the problem. So when you boil it all down, it comes to this. Agent tracing isn't a nice-to-have. It's not a luxury. It's an absolute necessity. If you're building a serious multi-agent system, having that clear line of sight into how your agents are talking and what they're deciding is non-negotiable for building something that actually works reliably. And really, that's the question you have to ask yourself. Your agents are out there making thousands of decisions on their own. With agent tracing, you can finally have confidence that they're making the right ones. Thanks so much for tuning in.